Hi guys, so this video is on exponents. So let's go over some notes that we took on exponent. An exponent is a math operation that causes repeated multiplication. All right, and the key word for this definition is repeated multiplication. Some of you guys want to add, some of you guys want to subtract, or just do a single multiplication. This is repeated multiplication, and you'll see that in some of our examples. So exponent, math operation that causes repeated multiplication. All right, so this is what an exponent looks like, okay? And this big 2, we're going to label it, this big 2 is the base. And something that I told you guys to write down is think big base, right? The big number is the base. It likes to show off it's the big number. And this tiny little guy right here is the exponent. All right, which is going to cause repeated multiplication. So what does this 2 and this tiny little 3 mean? We read this 2 to the third power. That 3 is going to give this big 2 that likes to show off all this power. It's going to cause some repeated multiplication. So this base tells us what number is being repeated, multiplied over and over and over again. This exponent tells us how many times. Okay, so what this equals is repeated multiplication. We are going to multiply the 2 3 times. So 1, 2, 3. 3 times. Okay, so that exponent again is telling me how many times. We don't see that exponent again. It's just telling us how many times. Remember that big base is the one that likes to show off. That 2 is the one that we're going to see over 1, 2, and 3 times. Okay, and then you can use your calculator and type this in. Well, what does that equal? 2 times 2 is 4 times 2 is 8. So this is going to eventually equal 8, but that is how we evaluate an exponent. So again, our base is the number that we see over and over and over again. Our exponent is just telling us how many times. It's really small, it's really shy, it doesn't like to be seen, right? We don't see it again. We don't see it again over here, but we do see that 2, that big base, over and over again. And it's being multiplied. We're not adding 2 plus 2 plus 2. We're multiplying 2 times 2 times 2, okay, which gives us 8. Now, an important thing to remember is do not multiply the 2 and the 3. We are not multiplying these 2 and the 3 right here. If I wanted to write 2 times 3, if I wanted you to multiply 2 times 3, I would just say multiply 2 times 3. I would just write 2 times 3. This exponent right here is telling me how many times. It is very different than 2 times 3. It's 2 times 2 times 2. So we are not just multiplying this right here. We're not doing that. We're doing this big 2 1, 2, 3 times. Okay, so let's do another example here. All right, so if we had 5, let's say to the third power, okay? So again, I'm multiplying my big base, my 5, and this exponent is telling me how many times. So 1, 2, 3. I'm multiplying that 5 3 times. So I'll label that right here. For you, this exponent is telling me how many times. 1, 2, 3. But the base is the one that likes to show off. It's really big. That big base, that's the one that we're going to see over and over again. Let's do another example. How about 8 to the 4th power? Okay, so my 8 is my base. It's the one that I'm going to see over and over and over again. How many times? 4 times. So 1, 2, 3, 4. Okay, and when we see it out, drawn out like that, what does that exponent mean? When we see it like this, that is called expanded form. I am expanding it out, right? Expanded form. Okay, and when I see it like this, and I see that exponent, that's called exponential form. All right, and you can see exponent in my definition there. So when you see an exponent, it's exponential form. When you are dragging it out, you're pulling it out so it's really long, you see that repeated multiplication, that's expanded form. Now, what is the answer? All right, so you can just, again, we can use a calculator for this. So you multiply 5 times 5 times 5. It's okay for you to use a calculator. You get 125. Okay, so this answer right here is called standard form. It's just your standard answer that you can see. That's the standard form. So 8 times 8 times 8 times 8 times 8 times 8, 4 times, is 4,096. So again, my answer right there is just standard form. Okay, so we have our exponential form. When you see the exponent, we have our expanded form when I'm expanding it out, showing you that repeated multiplication, and then the answer is the standard form. All right? So I want to show you one more thing with this exponent. Some exponent that you guys might think is really hard, but it's really, really easy. So what if I had some number, let's say 9 to the first power, right? This isn't meant to trick you or anything. I have a 9, how many times? Just one time. That's it. 9, how many times? 9, one time. What if I had 10? 10 to the power of 1. What does that mean? I have a 10, and how many 10s? Just one. 10 one time. Okay? So don't let this confuse you. What about if I had to the power of 0? What if I had 3 to the 0th power? Okay, now this is something that you might have to memorize, okay? Anything to the 0th power is always going to be just plain old 1. Okay, so I'm going to write this out for you. So you know, any number to 0 power is always 1. Okay, so I'll write this little 1. It's always going to equal 1. All right, so if I had, and this could be any number over here. What if it was like, I don't know, like 38? What about 38 to the 0 power? 1. Okay, what about 251 to the 0 power? 1. Okay, it always equals 1. It doesn't matter what this base number is. It can be, 1 to the 0 power still equals 1. Okay, so anything to the 0 power always equals 1. It always, always, always equals 1. All right, so now let's go over some fancy names here. Some fancy names. So we know what our base looks like. We know what our exponent looks like. Okay, so I'm just going to give you an example here. If we had 8 to the 2nd power, if you see this 2 right here, if it's to the 2nd power, this 2, we can also read this as 8 squared. Okay, so we can read it as 8 to the 2nd power or 8 squared. Okay, so you have to recognize, remember that word squared. If you see squared, that means it has an exponent of 2. Okay, there's one more. What if it's 8 to the power of 3? One more fancy name here. If you see an exponent of 3, you're going to say 8 to the power of 3 or 8 cubed. Okay, and we'll talk about this a little bit in class, why it's called squared and cubed, but for now, all you need to know is these fancy names. Any number, if it has the power of 2, it's going to be squared. If it has the power of 3, right, the exponent is 3, it's going to be cubed. Okay? So let's go over this. I'm going to give you an example problem. How about 65 to the power of 2? How do you read that? 65 squared, because I have this 2. It's squared. What about 65 to the power of 3? I can read this 65 cubed. All right, what about 3 to the power of 2? 3 squared. How about 3 to the power of 3? 3 cubed. So if you see this 2 right here, if you see that small little exponent of 2, power of 2, you can say that it is being squared. If you see that this power of 3, let me use a different color. If you see that it has an exponent of 3, power of 3, it is being cubed. Okay, so these are some fancy names for us. All right. One last thing I want to go over is this little trick. 10s are really, really, really cool. Okay, I'm going to show you. 10s are really cool. And again, you can use a calculator. You don't have to memorize this or anything. So 10 to the first power, what does that mean? I have 1 10. right? I just have plain old 10. Okay, 10 squared, our new vocabulary word there, our fancy name, 10 squared, what does that mean? It's 10 times 10. You can type that into the calculator, which is 100. All right, how about 10, new fancy name, cubed, 10 to the third power, what does that mean? It's 10 times 10 times 10, which is 1,000. Let's do one more, 10 to the fourth power, which is 10 times 10 times 10 times 10, 4 times. That's going to be 10,000. Now, do you guys see any pattern here? We went over in class, so hopefully you memorized this, but you remembered it from class. What's this pattern that we see here? So what did I add to this 10 to get 100? What did I add? Did I do anything there? Well, the only difference is I added a 0 right here, right? Okay, what did I do to this 100 to get to 1,000? There's 100, there's 100. All I did was I added another 0. So you'll notice the little trick here is that for tens, what you need to do, if you see 10 to raise to any power with 10 with any exponent besides 0, we know anything to the 0 power is 1. All you have to do is write a 1. Write the number 1. Oh, write the number 1, and then look at your exponent. The exponent tells you how many zeros. The exponent is going to tell you how many zeros. Right, so we see this 10 to the first power, this 1 right here. Well, I know I have 1 0. 10 to the second power, 10 squared, got 2 zeros. 10 cubed, got 3 0. 10 to the fourth, I have 4 0. Now, does this work for any other number, 10 raised to whatever it is? Yeah, it does. You can say, what is 10 to the 10th power? Exponent of 10, so 10 zeros. What's 10 to the 563rd power? 563 zeros. Okay, so this is our little trick that we went over in class. And I hope that helps with exponents.